and Lauri may have some additional items when she joins, but we can get started. I guess just before we get going, greetings to all. I'm your host for this evening. My name is Kirsten, Kirsten Pedersen. And just wondering if is there anybody new on the call or in the meeting room this week? No, sounds like there is nobody new. Okay. All right. Sounds good. So we're gonna actually start with some unfortunate news, but Dave Robinson, if you would be okay to just talk briefly, I guess, about the sudden passing of I guess the Edmonton RASC member Bruce McCurdy.
Yes. Oh, really? Wow. I had to write this down so I don't get distracted or broken up during the process.
Alex, the microphone closer.
Last Wednesday morning, I got a message from Zach, my daughter's partner at Edmonton, that Bruce McCurdy, one of my longest and most valued friends, had died suddenly the previous evening of a heart attack. My wife and I were devastated by the news. Many RASC members in Victoria and elsewhere in Canada knew Bruce from his long-term involvement in the RASC in a variety of ways. Some had met him in person at a GA or another RASC event. Some knew him as past president of the Edmonton Centre. And many longtime RASC journal subscribers knew him as the author of a regular column entitled Orbital Oddities. He was also a longtime contributor to the Observer's Handbook via the sections The Sky Month by Month and Lunar Observing. I knew him as one of the first to welcome me to the RASC some 30 years ago. We quickly became good friends as we shared a love of observing classical music and NHL hockey. My wife Julia and I became even closer to Bruce and Anna, his wife, when Julia started doing fabric art, since Anna was a long-term quilter. Last June, we enjoyed dinner at their place in St. Albert with their son Kevin as chef, and Bruce stayed with us here in July while visiting his sister. Bruce was a transplanted Newfie from St. John's and came to the music stuff via his father, who relocated the family to Edmonton to become music director at Concordia College. Bruce and I spent many hours together at the TELUS Science Center Observatory in Edmonton. He was a fixture at the observatory, introducing the public and school kids to the wonders of the night sky. I'd guess thousands of hours volunteering over the years. Many, many evenings, if he knew he was going to be there, I would join him and help open and close the roll-off roof and set up telescopes and engage visitors. Bruce was an expert at the latter. He had a patient and friendly approach to visitors. He was a bit like an encyclopedia of astro knowledge and numbers particularly. The science surrounding them was his passion. Bruce's love of hockey resulted in him being part of the Edmonton Journal blog, I think for about 9 years, called The Cult of Hockey. His mind was a steel trap when it came to players, their histories, and stats. A new player would show up at a team and he could tell you what junior team he played for and what his scoring stats were. Of course, Bruce was a huge Oilers fan. A measure of the respect fans had for him is the miles-long tributes to him being currently published in the Journal of the Edmonton Journal Cult of Hockey. And I've got a little poem I will read to you from one of those people who just knew him through the Cult of Hockey. Tracy Lane. He wrote of ice and skates that glide, of goals and grit and hometown pride. He saw the game at every star, a frozen pass, a world afar. Now silence falls where stories grew, but in the night sky's deepest hue, a light still shines, both sharp and true. We love the game, he knew. On the Saturday before he died, Bruce texted me a photo he took while on his daily walk in the St. Albert River Valley. He had his hand out in front of him with his index finger extended, and sitting on his finger was a downy woodpecker.
Wow.
I immediately called him to say thanks, and there followed an hour-long talk on all the stuff that linked us together. 3 days later, he was gone. I miss you terribly. Rest in peace, my friend.
It's very good.
Thank you so much, Dave, for sharing that and for saying those words. Deepest condolences on the passing of your friend.
His celebration of life will be held at the TELUS World of Science in Edmonton on June the 22nd. Memorials, if you want to donate something, there's a Ben Stetler Foundation that daughters have for a disabled fellow who was close to the team, or the Heart and Stroke Foundation. Thank you.
Thank you.
Great, thank you so much.
I'd
Okay,
like to say that this is reverberating around the whole country. I was just at an editorial board meeting for the National Society, and I understand there's going to be something about him in the upcoming journal, and probably the handbook as well. So yeah, this is difficult for a lot of people. So, and we pass along our condolences to his really good friends like you, Dave. So.
We had a nice hour-long conversation with Anna just this afternoon.
Peter Jenneke was just asking if he had been sick.
No, he'd had some blood pressure issues, but it was very sudden, unexpected.
Hey, any other thoughts on okay, all right, I think we'll turn it over to David Lee to talk about the science fair and book prizes as well as the book launch. And I just realized as well that after David speaks, Gary Sedun had asked for another kind of prize-related item to be spoken for. I'll do that on Gary's behalf. But go ahead, David.
All right. I see Randy's already got a picture up. Yeah, so 24 hours before, a number of us were out at UVic judging the Vancouver Island Regional Science Fair. I'm trying to remember everybody who was there. Lauri was there, David Payne, myself. I think Les, were you there? I think Les was there. I remember.
Yes, I was there.
Yeah, I don't know about anybody else, but we saw some pretty amazing projects. I have to say, being the age that I am, I'm always impressed and refreshed by the youth or the new generation of young scientists. So we did see a number. Lauri and I kind of agreed to kind of look around to see what kind of astronomical related projects there were, and we found two that we really liked. I wish Lauri was here because I only saw one of them, but maybe later when Lauri arrives, she can tell us about the one that I didn't see. So Randy, can you let me switch over to to my screen?
Yep.
And it looks
Thank you.
like Clark just arrived, David.
Oh, excellent, excellent. All right. So today was the ceremonies, and that kind of explains Randy's garb. And I think, Randy, did you say that you were the only one wearing a tie today?
You'd be surprised. Not part of the Victoria uniform.
Anyways, it was quite a boisterous crowd. Randy was the MC, and he whipped everybody into a frenzy. I can't believe how loud that many kids can be in a room, but they are. Yeah, it was wonderful. Anyways, we were able to present, or I was able to present two book prizes. One was for a rocket science project, and that's the one I didn't see. So when Lauri is able to, maybe she can chime in on that one. I did see the one called Plants on Mars that Thea McCurdy did, and it was quite interesting. She went on to tell me about acquiring some soil, which was Mars-like. Obviously, she couldn't get any real Mars soil, so apparently you can get or acquire soil which is like a replica Mars soil. So she went on to sort of create a experimental design where she planted different kinds of seeds in the soil, and then she produced a report on that. So I was quite interested in it. Actually, both these projects were hoping to get onto Astro Cafe or also at the museum for International Astronomy Day. So one thing that I asked the two, I got both up on stage, and I asked them both to look at the two books that I had with me in my hands, and I said, "Do either you have either of these books?" So they said no. So I just randomly handed. I don't know who got which one, but everybody in the audience probably will recognize Nathan's books. His first one, Cosmic Wonder, and his most recent one called Language of the Stars. So, sorry, I should mention the people's names. So it is rocket science was Linnea Meyer, and she's grade 5 from the Pacific Christian School, and Plants on Mars with Thea McCarty, and she's grade 6 from St. Michael's University School. So yeah, I congratulated both of them. They had good projects. Lauri, are you on board yet? Does
Yes.
anybody? Lauri, can you comment on the rocket science one? I didn't see that one.
Oh, sure. Yeah. So, Linnea is a little one who did a project on um, uh, what happens when you change the fins on a paper rocket that she was able to let go. She had a compressor, an air compressor, and then a rocket launcher, and you just simply make a paper launcher that she made different kinds, and she made different fin shapes and sizes, and had them all she had them all completely done. She worked on exactly how they would be put onto the little paper launchers, and she did a very nice little science experiment with keeping some of the things, very, as controlled as she could, and did uh, different numbers of launches. So she had like different trials, and she had all of her work up on the board, and so it was really quite fun. Her hypothesis did not turn out to be the one that she thought would be the better one, and that's always really good when you actually end up with a different hypothesis than what you thought. So she was really quite cute, and I enjoyed talking to her. So yeah,
Well, that's
hopefully she'll be
excellent.
able to come up to do that.
Yeah, I'm really looking forward to that. I want everybody to see both these projects. And by the way, I mean the other projects obviously were really good as well. I think both these projects I won some kind of prize this afternoon. Okay, so
David and Lauri,
hmm.
I
Yes.
think there were more astronomy adjacent projects this year than typically.
Yeah, there was one that I think I missed because I noticed there was somebody that came up on something called solar shadows. I didn't even see that one.
Yeah.
So we
Yeah.
missed that one.
Looking at solar panels at different angles.
Oh,
And
okay.
Oh, okay, yeah, and I mean there was a young little girl who was in grade 4 who did one on what happens to stars.
yes,
And she was very interested in what happens to the different kinds of stars when they explode and die and that kind of thing. And she was just little, and
Quite
I mean
young,
her.
right?
But yes, she was really very young, and but she really actually did know quite a bit of quite a bit of of the information. It was really quite amazing. She certainly knew more about stars than I certainly did at any
Oh
grade 4
yeah,
age that I was ever
I
like
I
that.
I was quite amazed. I was wondering whether I should hold back in terms of asking her interesting questions, but I didn't. And she obviously knew her stuff.
Yeah,
I told
she had some help.
oh, I'm sure. But
Yeah,
I told her about T Corona Borealis because she had actually showcased a nova, and I said,
yeah,
"Well, there's another kind of nova." So she seemed quite interested by that.
yeah.
Yeah.
So we've invited her. She didn't do an experiment. She basically did a study, and she'd had some help with where to go to get her information, and had that kind of thing. It was obviously done. She'd had help with some of the work, but then she did all of her own work when she did the little poster that she put on. But so I have told her that I'd love to be able to get to speak with her teacher, and maybe we could come out. The FDAO could come out to her school. She was from a George
George.
J
Yep.
school, and I mean they don't have an awful lot of money to get buses to come up to the center or anything. And she'd never been up to the center of the universe before.
Mm.
So I think there's a real possibility there to kind of to try to get her very interested in kind of coming on board a little bit more because her interest was really there. So that was good.
Yeah, absolutely.
Yeah.
Okay, so here's the segue into I guess a semi-ad, I guess. So tomorrow night is Nathan's book launch for his latest book called The Language of the Stars. So I don't know if there's any tickets left. I bought my ticket last week. I think it's around $5 or something like that. And just like last time, he's going to be interviewed by Bob McDonald. So that's at between 7 and 8:30 tomorrow night. And if you want any more information, ask me or just Google Bolin Books, and you can find any information that you need on that. That's great. Okay, thank you, Kirsten.
Okay, thank you, David. Yeah, Gary Sedun had asked. I guess there was another kind of item of note. I had never heard of these before, but apparently there is I guess a series of awards called the Breakthrough Prize Foundation. And I guess these were created, they're popularly known as the Oscars of Science. And they were created, I'm not exactly sure when, but they were created to celebrate the wonders of our scientific age by founding sponsors Sergey Brin, Priscilla Chan, Mark Zuckerberg, Julia and Yuri Milner, and Anne Wosiski. So I don't know most of those people, but this is a series of awards that's presented, I guess, each year in Los Angeles. and the prizes are significant in terms of monetary value. And congratulations go to, and I'm going to say it wrong. Her name is Dr. Maike or Maike Van Kooten. She is with the Herzberg Astronomy and Astrophysics Research Center here in Victoria. And this was announced on the media, I guess, a couple of days ago. I guess she had been aware of winning the prize for quite a number of months, but I guess was, obligated not to reveal that in any way publicly. But I guess the prizes were announced in Los Angeles April the 5th. And so she won. Now she won this year's. There's a number of prizes, some of them worth millions of dollars. But Dr. Van Kooten, she won the New Horizons in Physics prizes, which honor early career researchers across a wide range of fields. And there was a number of winners, but in astronomy, Dr. Van Kooten, along with her colleagues Sebastian Haffert and Rebecca Jensen-Clem, were awarded, I think it was $100,000 for, and that's very much on the small side of these awards. Some of them range in the millions. But they have designed and enabled novel techniques for extreme adaptive optics, which are systems that compensate for the effects of Earth's atmosphere on light-reaching terrestrial telescopes. And their work promises to enable the direct detection of the smallest of exoplanets. So we have a local celebrity here at NRC Victoria Herzberg Astronomy and Astrophysics Research Center. And she, on LinkedIn, she's currently listed as a researcher with NRC working on developing adaptive optic systems. So it's pretty amazing. She's been recognized now internationally, and it sounds like the work will have a wonderful effect on future research. So, yeah. Okay. So Natasha, did you want to talk about the Artemis mission?
Yes, sure. If Chris is here, it might be more appropriate for him to speak to it, but I'll just share my screen really quickly. Where did that button go? Share. Okay. So yeah, it was recently announced that this is the new crew mission badge for Artemis 2. And we have here the astronauts that are going to be, the names of the astronauts who are going to be on the mission. And then the rest is actually just a description of the symbolism. So I think what I'll just do is put a link in the chat to this description. Unless Chris, you wanted to add anything?
Oh, this is, I guess we're about a year away from the launch now, but things are moving along nicely with Artemis too, and I must say I was feeling a little nervous about how how or when it would go, but it just seems to be coming along. They're putting the rocket together down at the Cape. The astronauts, I think, were doing splashdown training a few days ago, and but when they start doing things like putting out their patches, it kind of is further signs that they're serious about this flight. So I think I'll leave that there.
Okay. So as soon as I find the link, I'll put it in the chat. But it talks all about the symbolism of the imagery, so it's quite interesting. That's it.
Great. So Randy, do you want to talk about zodiacal light?
Yes. Because I got a request. I always like requests. Okay, so it's a topic that I know so very little about, and people who went and visited Gary in Arizona took several pictures, which you can find in Zenfolio. This is one of John's that he took in 2013, and so what you see is close to the sunset. You see this band of light going up, and there's no way that the ancients didn't know about it. It was in dark skies, you see it, and that's all they had back then. But it continues to be something that is being studied. And I got this request from Natasha. Do you know if there's been a presentation on zodiacal light, which I understand can be best viewed in spring and autumn? And she quotes a bit of the RASC website. And so always happy to take a challenge. I got into this, and I have to tell you, I cannot do this in one presentation. So this is a part one, and it's basically a book report. So yeah, this is what you get in the handbook. I don't expect you to read it, but it's a very nice write-up by Roy Bishop, and it's quite up to date, and it goes through things. But I am kind of curious, how many people have actually knowingly seen zodiacal light? Dave has. Way to go.
I saw it.
And Joe, and Leslie, and Peter, and Lauri. Look at all you guys.
I saw it at Galapagos.
Even better. Wow. Okay. Anyway, so I'm just going to give a book report on this thesis that I read this weekend in quite some detail, and it's excellent, and it's very readable. And you know, like, part of what makes it readable is the author puts in lovely epigraphs, like dust in the wind, all we are is dust in the wind, from the Kansas song. And he quotes the Bible, you know, for dust thou art and unto dust thou shalt return. It's written in a, well, the parts that are readable. He doesn't shy away from getting into some pretty messy math and programming. And I'm afraid this is going to be very texty, because it was a texty sort of book, and lots of people are reporting on this thesis. It was quite important, but they kind of don't go much into the detail, and there are beautiful details. And one of the main ones is that he took a hiatus. So it says, this thesis documents a body of spectroscopic observational work on the zodiacal light, which was completed 30 years ago. The results were published in 2 papers, in Nature 1972 and Monthly Notices of the Royal Astronomical Society 1974, and who he worked with. And later in this introduction, he goes, I inherited this spectrometer and spent 18 months entirely rebuilding and updating both the optics and electronics in preparation for obtaining essentially the first viable set of radial velocity measurements all around the ecliptic of the zodiacal light. The writing of my thesis was virtually complete in 1974, but the submission was deferred due to various pressures. Having returned to work in 2006, 32 years later, I'm happy to submit a complete and substantially updated thesis in 2007, in which I am now able to offer many new perspectives because of the research which has taken place between 1974 and the present day. Now, I gotta say, there's lots of people who do not finish a thesis. Not many people pick it up. And the other thing that's interesting is the data was still relevant. It wasn't repeated, although there had been a lot of stuff, and he talks about this. But his measurements were good and still publishable, which is remarkable. 32 years. So, excellent historical review, including the first.
Randy, did you discover why he took that break?
Oh, we might talk about that later.
Oh, good.
So Cassini, the great Italian astronomer, became the Astronomer Royal in Paris, did a lot of work on it, and he basically came up with the modern view that it is dust in the wind, dust in the solar system that is reflecting, or I don't know what the difference is, but May is very keen on saying it's not really reflection, it's scattering. So I don't have enough optics to know what the difference is. It looks like reflection to me. And then, oh, this is delicious. So many people know that Commander Perry was sent by the Americans in 1852 to open up the Japanese Empire. He took a man of war, sailed into Japan, and said, you guys, you may think you're an island, but there's a whole world out there, and you've got to open up. Well, the chaplain aboard the ship, one Reverend George Jones, spent his time charting the zodiacal light, and it's the first major study of this effect. And he, all the way across the Pacific and back, and at many different latitudes and in cross seasons, he took hundreds, and this is just one page. There are the book is maybe about 40 pages, and then there's like 300 pages of diagrams like this one, and they're beautiful, all hand drawn, and shows where this brightness was with respect to the stars in the Milky Way. Okay, so I'm just going to read bits. The 3 years eventually extended to 4 of my initial appointments at Imperial College Infrared Astronomy Department. Some people think that it was about infrared spectroscopy because he was in the infrared astronomy department, but in fact it was completely visual light. Involved me firstly in an attempt to make observations in the Alps, but they ended up having just to dig it up out of 6 feet of snow. So his first field season was a wipeout, but then they got permission to set up on Tenerife in the Canary Islands. They had just set up the observation area there. They put a road up there, and they got permission to put up a hut, and they set up this revamped spectrometer up on the mountain in this area. He says there's about 70% clear skies up there, which is interesting. I thought it would be more, because I know they say that it is the second best place in the Northern Hemisphere to put an observatory. And they might end up putting the 30-meter telescope there if they can't put it in Hawaii, which is the best on Mauna Kea. Anyway, 70% of the time they have beautiful clear skies and excellent seeing. So this is the hut that they built, and he makes some sort of comment about how difficult it was to use English design in this Portuguese culture. There was a cultural disconnect in how to read blueprints. Anyway, it sounds like there was a whole story there. Anyway, just for fun, over the 30 years, he took a picture from the same site. And so you see the building over on the right is the same, but everything else is different. Okay, so radial velocity. So the deal is, if the hypothesis is correct, that we are looking at the scattered sunlight of dust in the solar system, then there is, it's going around, the Earth is going around, and depending on the elongation, the angle between where you're looking and where the sun is, you're going to see different speeds of the dust going around. And so the first thing is to make measurements of this radial speed as a function of angle between the sun and the antipode of the sun, and then around towards the sun again. So you're looking around 180 degrees. And then, based on that data, what does this tell you about this dust? And so, the same thing when a siren goes coming towards you, ba 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 ba, and then as it goes by, ba 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 ba, it gets lower because of what's called the Doppler shift. Light does the same thing that sound does. And so if you are expecting a spectral feature, if you're expecting sunlight with, let's say, hydrogen in the way, and it makes this particular looking profile, then, so this is for an elongation of 30 degrees, so 30 degrees away from the sun. If the dust is going in the same direction as you, you would see it looking a bit more blue. And if it's moving away from you, you would see it looking a bit more red. Okay? And so a review of the period of my observations of the zodiacal light, 1970 to 1974. So it was the intention of this PhD study to fill in the gaps and uncertainties left in observational data in 1970 and to make a comprehensive survey of a Doppler modified Fraunhofer line. Fraunhofer was the fellow who first saw that there were gaps in the light that comes from the sun because of cold elements in what is called the corona. Okay, so you have the photosphere, makes lots of light, and then in front of it was this free gas, and there were these what are called spectral lines or Fraunhofer lines. So along the ecliptic plane at all elongations from the sun. So that means at all angles with respect to the sun along the ecliptic, along the plane that the sun and the moon and the planets all go in. And the zodiac, all the constellations, Gemini, Aries, Cancer, all of the ones that the horoscope people go crazy about. Okay. The spectral line chosen was magnesium 1, so singly ionized magnesium, because of its hoped freedom from emission line contamination. Part of the thing that was interesting is he does see that as well as sucking up light from the sun in the Earth's atmosphere, there's some magnesium that is emitting light, and that's a difficulty that he found. And then with a new pressure scanned Fabry-Perot interferometer. So that was the big thing. And is that the same thing that coronoscopes have? Is it called a Fabry-Perot interferometer when you have an H-alpha coronagraph? I think it's the same. I think it's the same sort of technology, except this one can change the frequency. So this is a spectrum of what light at 5,183 angstroms looks like, and this is caused by magnesium, and I don't know what all these other lines are, but this is with very high resolution spectroscopy, and the one that he built has a 1.5 angstrom resolution. And he argues why that's a good thing, because it lets in quite a lot of light. It's in that sweet zone. If it were less resolving, then you wouldn't be able to see the sorts of dust speed that he was interested in. But if it were tighter, then if it were tighter, you wouldn't get enough light, and if it were bigger, it would wash out your signal. So they figured that 1.5 angstroms was the right amount, and they're going to kind of sweep through these wavelengths and see where this minimum shows up. Does that make sense? Okay, so here he is with the, I'm going to call it a chelostat. COELOSTAT. Anyway, it's a way to, the spectrometer is in a building, and it needs to be in a temperature controlled building, and it's very big and very fragile. And so no matter where you're looking in the sky, you want to be able to get the light to come into the building in a nice horizontal beam. And so they built this chelostat. And then inside, so the light comes from that chelostat. They have kind of a disk mirror so that they can check what the ambient brightness is of all the light. And then it goes through, collimates, and then you have this thing. Okay, so you have these two plates which are partially reflective, light goes bouncing back and forth between these two plates, and different frequencies are going to get through depending on, it's called constructive and destructive interference. Don't worry about that. What is cool is you can change the frequency by changing the pressure of the gas inside this pressure pot. And so they had a cylinder with nitrogen, and they would put in 6 atmospheres of nitrogen, and they calibrated it very carefully. There's lots of stuff about calibration. And they would put in 6 atmospheres, and it would see the smallest wavelength, and then they would let the nitrogen leak out. And as the nitrogen leaked out, then it changed the refractive index of the gas, changed the frequency or the wavelength that you saw through the spectrometer, and then they counted how much of a signal was coming through. And it was very low, like you're counting photons. You're not counting bunch of light. This is an extremely dim light that they're looking at, and then you're only looking at 1.5 angstroms of that whole spectrum. And so this photomultiplier is actually right down, counting down to photons. Okay. Oh yeah, I just put this in because this was the good old days when you would take your stack of cards to the computer center, and if you're lucky, you could get 2 runs a day. And then they would come back and they would say, you had a syntax error, do it again. Or they would say, the card reader buggered up, do it again. Anyway, he did all of his work this way. And then instead of having a printout at the end, he would have it print out new cards so that he could use those as inputs to other programs. When I first did computing in grade 10 and 1976, that's exactly the way that we did it. I see a hand from David Lee.
Yes, Randy. Did you ever drop your cards?
Yes.
I have seen people drop their cards. I have not.
Did you not know the trick about using a felt pen across the top of them so you could realign them?
Ah, very good.
That's a tip from my past life.
We actually punched number cars in 1960.
Well, yeah, that's a more official way of doing it.
There are hand-drawn diagrams on this thesis. I love this. This is showing when the moon set and moon rises, and when sunrise and sunset is, and where the Milky Way is, because you have to avoid the Milky Way, and it's just glorious. Again, I enjoyed reading it. A lot of times you say, a thesis is just a word hash, but I really did enjoy going through this thesis. And this is his raw data. Well, no, this is already really cooked. This is after all the calibration and the equivalent of what astrophotographers would call doing their darks and their flats and things. These are very, very cooked data, but he had two observing periods in October 1971 and April 1972. And this is one spectral line. I don't know if you can see, but that's -4 to +4 angstroms from where the magnesium line was expected to be. And this was 35 degrees from the sun, 40 degrees from the sun, 45 degrees from the sun. Okay, and there are pages and pages of these curves. And he goes into detail how he fits them. And then you put them all together. It's pretty noisy data.
Yeah.
Anyway, this was his 1971 data in the autumn equinox period, and this was in the spring equinox period, and some other data that was done before. And then he says, well, that's what I did in 1974 when I dropped the thesis. And then what is this? 1984. Here's another data set. So there's a lot of question about how constant zodiacal light is. And one of the interesting things is, why is there so little interest between Cassini in 1685 and that Reverend George whatever in the 19th century? Is it because that there just wasn't as much zodiacal light during that period? Nobody recorded stuff about it in between. So interesting things going on. Anyway, so one of the things they're very interested in, how to interpret this curve. Oh yeah, and this is kind of part of the story is later, well after 1974, and they had spaceships that were going up and actually measuring this dust. And they discovered with this Ulysses spaceship that there was actually some dust coming from other directions, which had to be interstellar dust, not interplanetary dust, because most of it is assumed to be interplanetary dust. But he says, if my interpretation paper had been published as planned around 1975, this discovery might have been less of a surprise. This is a source of both satisfaction and frustration to me from the position I occupy in 2007, but a full discussion of the possibility of an interstellar component of the zodiacal, oh dear, I don't remember what that is. Mirroring my writings in 1974 based on our measurements will be offered in chapter 4. Yeah. Okay, so jumping to the end, my conclusions at the time, so in 1974, is that, first of all, the Earth's atmosphere has an emission component of Mg singly ionized. The zodiacal cloud, that's what ZC is, that these dust particles are about 1 micron in orbit around the sun. And that's very interesting because if they get even smaller, then they get swept away by the solar wind. And if they get bigger, then they lose energy by something called the Poynting-Robertson effect, and they get sucked in towards the sun. And so there's this kind of sweet spot in between where they live, but only for about 1 million years. So this is dust that is continuously being regenerated. This is not something that from the early days of the solar system that just didn't get turned into a planet. This is new dust all the time. 1 million years is a snap of the fingers in astronomical terms, right? Right. We found no evidence for contra-rotating dust. Now that's important. That means that everything is going along with the planets, not going backwards. Okay, and that is part of the reason that they know that it is it's part of the solar system. Gegenschein, that's a whole other topic, but that is the reflection of dust particles opposite the sun. Anyway, it seems to be moving away, but they don't know why. And then they say, and then everything that's happened since has been pretty supportive of the stuff they saw. And then near the end of the book, the final 3 figures which follow are artists' impressions. And this is the last diagram. It's a beautiful picture. So here's Saturn, Jupiter, Mars, Earth, Venus, Mercury, and he intentionally leaves out the sun. And this is where the dust is by his best model. And he draws in an asteroid collision, which, you know, could happen at any time. That's the sort of thing. And then it kind of turns into this, by collisions and things, it turns into this zodiacal cloud between Jupiter and near the Earth. So this is his best model in 2007. And he ends off, this is the very, very end of the thesis. Perhaps in the near future, kinematic studies of the material around us will resume their rightful place alongside photometry in unraveling the secrets of the formation and evolution of the zodiacal dust cloud. And then he just adds, the artist, by the way, is me. This is not a young doctoral student. This is a mature author who is looking back, and he's a bit cheeky. But that is with good reason, because Brian May actually is the lead guitarist of Queen. For anybody who didn't gather this before in the talk. And that's where I'm going to stop today.
So that explains the absence.
It does.
There you go, Natasha, part 1.
Thank you so much, Randy. That was fascinating.
And the story gets even better. That's the crazy thing. There's recent data that is just wonderful.
Great. Okay. Well, thanks. Thanks for that, Randy. And
I'll tell you next time.
yeah, and thanks for the picture of Queen there. That was a really nice way to end the presentation. Just wondering, before we move on, I see it's not quite 8 o'clock. Just wondering, Lauri, I know you joined the call a little bit late. Did you have any announcements or news or anything about the center that you wanted to say?
I think the only thing is this coming weekend is an open house up at the center. So it's from I think 6 to 10 on Friday night, and 3 to 7 on Saturday. This is a chance for people just to simply come up, have a look through the center. We've got tickets going at various times, at various hourly intervals. We only expect people to stay up for an hour and a half or so. And we'll be giving tours. We'll be doing planetarium shows. There's no speakers. We'll be doing a little bit of some things for the kids, but we're just wanting people that don't usually get a chance to come up or haven't had a chance to come up to just simply have a chance to look around, and then we'll give them some more information about star parties and everything else that is happening during the time. We're also just in the middle of applying for a couple of other grants for our school programs to keep those running, and we're going to be working on those before the end of April, and hoping to get a little bit of some cash out of a few different organizations that will keep us afloat, which would be really nice. I don't think so, Kirsten. I think that's just kind of all for now. Yeah, there'll be much more coming up at the center when we start getting our star parties going, everything like that.
So Lauri,
So-
for the open house, did you want people to bring up telescopes?
It would be great if we had, especially, it'll be daytime for sure. In the afternoon, like 3 to 7 will be afternoon and Saturday, and then in the evening it's 7 to 10. So there's a chance to put up maybe a little bit of some. I'm not sure what we would see by the sun. Would we be able to still see the sun going, or will it already have been almost down by that time? Maybe.
Yeah, maybe
I don't
almost
know. I'd
down.
have to look. But sure, if you'd like to bring up telescopes, that would be wonderful. The more the merrier always. So that's great. And of course, look up for the registration for the General Assembly, which is on the 26th and 27th of April. And get your tickets now. Yay. Okay. So.
Great, thanks, Lauri. All right, and then I'll just announce at this time, just a reminder to everybody about our monthly meeting that will be happening this coming Wednesday, April the 9th. It is at our usual location at the University of Victoria in the Bob Wright Center. The meeting starts at 7:30, and it's in the same location as we normally hold it in Lecture Theater A104. And I'm happy to say that we'll have our usual updates about what's up in the sky currently from David Lee. And then hopefully Chris Gainor will give us a bit of an update on what might be happening in space or space missions currently. That would be wonderful. And we also have a guest speaker on Wednesday, Dr. Toby Brown, who is an astronomer at the Herzberg Astronomy and Astrophysics Research Center with the NRC. And he is going to be doing a presentation titled Galaxies Under the Microscope: How the Latest Telescopes Are Transforming Our View of the Universe. And this sounds like a really interesting presentation about how Dr. Brown is using data from space and ground-based telescopes like James Webb and the Atacama Large Millimeter Submillimeter Array. And he's also going to be weaving in, I guess, some of his, I don't know if I'd say theories, but also, I guess, some of the other data around dark matter and cosmology, and some of how star formation and galaxy formation may be linked to some of these deeper questions around dark matter. So it actually promises to be a very interesting talk. So hopefully people will come out for that. Okay. All right. Well, it's 8 o'clock.
Sorry,
Yeah,
one more
hi.
thing. Kirsten,
Yep.
sorry.
Yep.
There will be a special announcement on for that evening, given by Chris Gainor and myself. So I'm not going to say anything more, but please come and find out.
Jeez.
Fabulous. Oh, I have no idea what it could be. Can't can't wait. Thank you, Lauri and Chris. And I forgot to mention as well that another benefit of coming in person is we have a coffee and gathering with coffee and treats afterwards, and it's really good. David, are we going to be recording this one or not?
I actually am going to. I don't know. I'm gonna venture into the unknown. I'm not gonna use a standard way that I do it. It's a little bit of an experiment, but I'm fairly confident I will have a recording out of it.
Okay, great. Okay, so that's fabulous. All right. Well, I'm happy to do a part of my Saturnian moons presentation. I guess the amount that people can stand. So we'll I guess we'll start that. I will
Yay.
I will load it up here.
This is the beginning of the serialization of talks.
All right. Okay. So everybody can see my screen?
Yep.
All right, great. Okay, so Saturnian moons. So what I'm going to talk about is I'm going to give a just a kind of a quick review of Saturn, talking a little bit about what's going on with Saturn before getting into the Saturnian moons. But so a quick review of Saturnian facts, and then uh, the timeline and history of the discovery of the moons of Saturn. And I don't know if I'll get this far tonight, but this is kind of a lead up to sort of the main purpose of this presentation was talking about the recent discovery of 128 new moons. And I'm sure everybody's kind of had an opportunity to review that. But the thing that kind of makes it um, not special, but the team that discovered these new moons of Saturn, and it brings the total up to about 274. And this kind of goes to the definition of moon, which is kind of what makes it easy because there isn't one. There isn't a standard. There is no, I guess, International Astronomy Union accredited, sanctioned definition of moon. NASA has provided a lot of really good kind of, I don't know if I'd call them benchmarks or sort of features about that, but we'll talk a bit about more about that later. But because some of these new moons, if not most of them, they're extremely small. They're irregular. They're certainly not round in shape. They're irregular moons, very small, but they still kind of meet this International Astronomy Union definition of or recognition of moon in the absence of an actual definition. So talking a bit about that, and then spacecraft to Saturn, some of the highlights there, some of the highlights of the amazing moons, and then not to give away the end, but there's an amazing mission still planned called Dragonfly that is planned to go to the moon Titan soon, within a couple of years, actually, assuming its budget doesn't get canceled by the current administration, but it looks like it actually will still be happening. Okay, so quick facts about Saturn. And I've included a picture here credited to NASA and JPL and the Space Science Institute, but it gives a perspective of how large Saturn is in comparison to Earth and Earth's moon. And it's 9 times wider than the Earth. Um, it's 1.5 billion kilometers from the sun, and its day So its orbital rotation um, of the planet is 10.7 hours. But what's interesting is its year, the orbit, the duration of time that it takes to actually orbit the sun is close to 30 years, which is obviously very, very long compared to our 365 days. It's a gas giant, predominantly hydrogen and helium atmosphere. It's believed it likely has a small solid core, but it certainly has no surface. And what's really, I think, interesting about Saturn is that it has some of the most violent storms in the solar system. Like wind speeds on Saturn can reach about 1,800 kilometers an hour. And the reason for that, the reason it's kind of got this extreme weather is that about 40 there these I guess science is estimating about 40,000 kilometers down into that kind of really dense hydrogen and helium atmosphere because of the pressure, like the atmospheric pressures that come down from they're down around 40,000 kilometers. Gases behave more like liquid metal. So, it has what's really interesting, this kind of photochemical cycle where water and lightning are interacting with the methane and some of the gaseous hydrocarbons that are in the atmosphere, creating kind of a raining soot that descends deep down into these cloud layers and atmospheric pressure that is, I think the estimates are that it turns into like diamond material, like hard carbon diamond, but that ultimately liquefies. The pressures get so extreme lower down that this molten carbon and liquid hydrogen acts as liquid metal and generates extreme heats, getting close to like 12,000 degrees Celsius in the interior, which generates these massive weather storms. There's this amazing feature on Saturn that it's called like the blue hexagon structure. It's like this similar to the Great Red Spot, I think, on Jupiter, but it's at one of the poles, and it's this blue turquoise hexagonal structure that has an eye of a hurricane that's massive, and it's been there for I don't know how long, decades or who knows how long, but it's incredibly huge. Um, Okay, Saturn's rings. There's a lot of them, but the main ones are labeled A, B, and C. And what's interesting about these is they're made predominantly of water ice, ranging in sizes from microns to tens of or hundreds of meters in diameter. And what's interesting about these, and we had kind of a good discussion about this at the beginner SIG, was the rings of Saturn are not considered moons or true moons, even though they orbit the planet. Um, but apparently the rings orbit as one collective, they orbit together. Like all of these particles orbit together. So I guess it's that feature that makes the rings of Saturn not considered moons, because theoretically if the definition of a moon is a particle or a satellite of a natural satellite orbiting something, then theoretically the rings of Saturn should be that, but they apparently the particles do not orbit the planet independently. So there's not an independent orbit of each particle. I'm gonna go with that, but feel free to jump in. That's about as good as I've gotten. But what's interesting is within the rings are these kind of ice moons that are made of the same material as the rings themselves. And there's about seven key ones that orbit, and they have their own independent orbits within the rings, and they're known as shepherd rings, or shepherd moons, and they keep the rings of Saturn stable and kind of in like this gravitationally bound circular kind of formation. Um, it's uh, it's interesting. Like the leading theory is that the rings are about 100 million years old. Like they're considered very new in comparison to the age of the planet, which is about 4.5 billion years. Like Saturn's estimated to be similar to the age of the solar system, but the rings themselves are considered young. And leading theory is that they've resulted from a breakup of a small ice moon, probably about 300 kilometers in diameter, that just got too close to the planet, and then it broke up, and it created this amazing ring structure. So, it's fascinating. Like 100 million years ago or 200 million years ago, um, there wouldn't have been this ring structure. Like and they're not estimated to last forever. Like at some point, several millions of years from now, they will be gone. So we're lucky. We're living in a time where we can actually see them. And this theory explains in part why the water ice particles in the rings are still so reflective because what was mentioned earlier this evening. I mean, the solar system is a very dirty and dusty place. And water ice, of course, collects dust and it gets dirty and dark. But the rings are still clean and reflective. So that's another kind of reason why they think they're so young. Um, so there's 274 confirmed moons in Saturn's orbit, or yeah, which is the most now in the solar system. 63 of those confirmed moons have official names. So when I say confirmed, the sort of internationally recognized body called the International Astronomical Union, which consists of the majority of countries, I guess, around the world. They confirmed the discovery of 128 small moons around Saturn, adding to the already large moon count. So these moons range in size from larger than the planet Mercury, which of course is the giant moon Titan, to ones as small as a sports arena. And just a little teaser for the future, both Titan and Enceladus are believed to have subsurface saltwater oceans. And that picture is a Cassini image showing the kind of the leaking saltwater, subsurface ocean leaking into space from Enceladus. Okay, so what is a moon? As already mentioned, there isn't an official definition of it, but NASA on its website has.
Canadian. Doesn't it get more Canadian?
Sorry? Did somebody have a question?
No, it was just one of our members needed to be muted.
Oh, okay. Okay. So moons are also called planetary satellites. And it's quite interesting. They can come in pretty much any shape, size, or type. They're generally solid bodies, and a few of them have atmospheres. I guess most planetary moons are thought to have formed out of the disks of gas and dust circulating around the planets in the early solar system. But not all of them have. Some of them are captures or have resulted from collisions between other kind of satellites or planet or bodies that are orbiting. So moons orbit planets, but they can also orbit dwarf planets. They can also orbit asteroids. apparently some moons have moons. And I've heard the term moon, but but it's like, so it's really a broad thing. The one thing I seem to have found is like this notion of an independent orbit, that it has to be independently, on its own steam, kind of orbiting another body. There were 891 confirmed moons as of March 25th, 2025, in our solar system. And 421 of those are officially recognized to be orbiting planets, as well as the dwarf planet Pluto. But there are 407, more than 470 confirmed moons orbiting other officially confirmed dwarf planets, asteroids, and trans-Neptunian objects. That's where the 891 comes from. Yeah, and then how a moon is named. Every moon discovered in the modern era gets a number first. Most significant moons get an official name. And it's interesting, when I say significant, I tried to figure out or research what that was. It seemed to be predominantly related to size, but not necessarily. I guess from an astronomical perspective, in terms of what makes a moon significant, warranting to actually get an official name from the International Astronomical Union, that is really up to the discretion of that body to determine what it would be in terms of significance. What is interesting, out of the 128 newly discovered moons of Saturn, none of them warranted an official name. Most moons in our solar system are named for mythological characters from a wide variety of cultures. Newer moons discovered at Saturn, not the new 128, but they are named for mythological Norse characters. Uranus is the exception. Uranus's moons are named for characters in William Shakespeare's plays, with destinations such as Ophelia and Puck in orbit. Other Uranian moon names were chosen from Alexander Pope's poetry. I think Uranus is a bit different. But somebody else at the beginner SIG mentioned that, and I haven't done any research on this, but they mentioned that there was a period of time just after Uranus was discovered that it was going to be called George. Fortunately, it didn't get called George, but apparently that was in the works. Okay.
It was after the King George at the time.
Oh, that's right. Thank you, Lauri.
Yeah.
It was yes, after King George. But fortunately, it didn't get called, well, it didn't get called George. All right. Just early discovery of Saturn's moons. What's kind of interesting about this is 8 moons were first discovered by the early telescopes. The largest of Saturn's moons, called Titan, the one that's just larger than the planet Mercury, it was discovered in 1655 by Christian Huygens. And then there was the next kind of largest moons, Tethys, Dione, Rhea, and Iapetus, that were discovered by telescope by Giovanni Cassini. Then William Herschel, Mimas and Enceladus, and Hyperion was later discovered 1848 by a team. including William Lassell. So these were the ones that were discovered early and by telescope. And then as technology improved towards the turn of the 20th century, there was more early moons that were seen from the Earth, but they were captured by long exposure photographic plate discoveries. So too small to be seen by telescope, but as soon as plate photography became, I guess, available at, I guess, some of the earlier observatories, that kind of thing, they were able to capture a number of these more smaller and dimmer moons. Okay. And so additional moons were discovered once we started to have spacecraft going to the outer solar system. And we have had it's interesting, Voyager 2, and Chris will know this way better than I will, but Voyager 2 launched first. It launched a couple months or a month or two earlier than Voyager 1. And it, uh, it had a Voyager 2, I believe, was the first to actually reach Saturn, if I'm not mistaken. Chris, please correct me if I'm wrong. But the first photographic images of Saturn were taken by Voyager 2. And
Actually, the reason the numbers were reversed was because Voyager 1 got to Jupiter and Saturn first, and then Voyager 2 followed to those two planets. But then Voyager 2 was the one that went beyond.
perfect. So Voyager 1 actually reached Saturn and Jupiter first.
That's
Okay. Thank you. Thank you for that. Thank you for that clarification, Chris. Yeah, I think if if I'm not mistaken, Voyager 1 had a much more direct path to Saturn and Jupiter, whereas I think Voyager 2 took a lot longer to get there, maybe because it had a lot more gravity assists in
well,
its.
yeah, it was kind of because of the paths that they chose for them, like where they would go by the planets for, for example, um, Voyager 1, they wanted it to go by Titan when it went by Saturn. And Voyager 2, they wanted it to go on a path that would take it towards Uranus and Neptune.
That's great. Yeah. And to date, Voyager 2 is the only mission that has reached Uranus and Neptune so far. And what's really amazing is so the Cassini-Huygens probe, and they're two separate things. I mean, the Cassini probe was an orbiter, and the Huygens probe, which was attached to Cassini, was an actual lander. It was built to get there with Cassini, but then to detach and land on the surface of Titan, which it did. Huygens probe landed by parachute on Titan in January 2005, and it returned data back to Earth as well as a number of photographs for about 90 minutes using Cassini as a relay to get the data back to Earth. And this is pretty amazing. Like the first landing ever accomplished in the outer solar system, and the first landing on a moon other than Earth's moon. So I just fascinated by this. Okay, so the discovery of the 128 new moons, and what kind of makes this special is the team that discovered them was, I guess it consisted of I guess, an international team, but it included Dr. Brett Gladman from UBC. And, there was the lead researcher was from Taiwan. And also there was team members from the USA and France. But Dr. Gladman, I guess, just looking at all of his publications, I mean, he's discovered many Saturnian moons, I guess, throughout a number of years. And the discovery was done by using the Canada-France-Hawaii telescope to repeatedly monitor the sky around Saturn between 2019 and 2021, combining multiple images. So I guess what's interesting is during this period of time, they found an initial 62 new moons, and then it was later they knew there were more. I guess during this time, they knew that there were more. So they revisited the same sky sort of night after night for 3 months in 2023. And through that process, I guess, of, mapping the same periods of or same parts of sky on all possible nights, they found another 128 new moons. So, yep, all of them are irregular, a few kilometers in size, and they suspect that they're likely fragments of small captured moons that were broken apart into smaller pieces by collisions with each other or by passing comets. So it's interesting after reading about this discovery in the paper. It looked like a lot of this research and interest in these kind of small moons was really kind of related to the whole kind of theory and I guess research being done around Saturn's rings and the whole kind of Saturnian system, the Saturnian moons, the structure of them, the rings, how all of this kind of works together in terms of that. So I guess studying the evolution of Saturn's irregular natural satellite population is kind of a whole big part of that process. And similar to the formation of the rings, I guess speculation or the evidence is suggesting that most of these small moons resulted from collisions again within about the last 100 million years. And I found this really
Wow.
interesting. Yeah, I found this really interesting graphic, and yeah, like there wasn't an actual name associated with the graphic, but it was on the Earth Sky website, and it was an individual who said that they spent, countless hours after the discovery of these new moons. They tediously charted all of the orbits of the 274 moons of Saturn, and then they put this up in the internet, and you can see like Saturn is right in the middle, that little tiny little yellow dot there in the middle. You can see Titan, the orbit of Titan, kind of it's in green, and there's a few of the other main kind of regular circular larger moons that are shown in green. And and what's interesting is not only the distance of the orbits of a lot of these smaller kind of the unnamed moons, but they've actually, the nice thing about the red and the blue is the red is showing retrograde moons. So a number of these moons are not going in the same direction as the orbit of Saturn. And that's another key clue that these moons did not form at the same time as the planet. Whereas the regular moons and the prograde moons, the ones that are showing in blue, are in fact going the same direction as the orbit of Saturn. So it's just kind of, I love this image because it just showed the scale of the Saturnian system. And yeah, that's quite, that would have been a painstaking process.
Kirsten,
Yeah,
can you go back?
yes.
So, are they mostly in the plane of the equator and the rings, or are they all over it with different what's the word for that? Inclinations.
Yeah, well, you can see the distance, Randy. So in the bottom, I guess left-hand corner, there's a scale of 10 million, you know, that line there, like 10 million kilometers. Like the planet Saturn itself, I mean, these most of these moons are like, you know, tens and tens of millions of kilometers away from the planet Saturn itself. That's how far out they are. Like the moon, the planet is way in there. That little tiny yellow dot.
Yeah.
And so the rings of Saturn, you can't even see them in this picture. Like they're so small in comparison to this great orbital structure. You can see the orbit of Titan, which is just outside the rings of Saturn. So Titan is orbiting Saturn outside of the rings. And you can see Titan there in green.
Yeah.
Yeah,
But is this
so
all in one plane, or is it like in a sphere around
I don't know. I am not sure about that. That's a really good question, Randy. And you know, the way the image looks, I don't know. Yeah, it sort of looks like they're all over the place, but who knows? They could be in a plane.
Yeah.
Yeah. Yeah, it's a really good question though. Okay. All right. Well, I can carry on and finish, or I can save the rest for another time. Any thoughts on that, or what do you think, Randy?
Like the
Should I?
serialization, I think you should
Stop right here.
stop there and then we get to have more of you another day.
Are we at a
Okay.
cliffhanger?
Yeah, we.
All right. Okay, that sounds good. Because yeah, no, it's probably a good place to stop because when I start talking about some of the specifics of Titan and Enceladus, I really ramble. So I'll stop now.
That was fantastic, Kirsten.
Great.
We're
I'm glad you
missing
enjoyed it. Okay, so maybe at this point, this would be a lovely time to have some pictures. Ken, you mentioned you've got some pictures to show us.
Hold on, I
Oh.
have a question or two. I'm very curious. Has anybody in our cohort here seen any of the moons other than Titan? Because Titan's easy to see, but I don't think I've seen any of the other ones. Just you know, at the eyepiece.
I think.
You have,
Yeah, I think so.
Alex.
Wow.
Anybody else?
For me, it's hard to know because I mean, could have been a star, right? But Titan's very obvious, so.
Brock is saying he has.
Good for you, Brock.
I've seen more than Titan for sure.
Mhm.
I'm sure I've seen upwards of 4.
Have you imaged them, Brock?
No,
They're a different
You've got
exposure,
a-
aren't they?
you've got to way overexpose Saturn to get any visibility on the moons, and so
Mm.
I haven't done it.
Has anybody seen spokes in the rings? No. I did once at Malcova.
I've heard of them. I've never
Yeah.
seen them.
Wow.
Just at Cobalt.
Sorry, David, did you say spokes in the rings?
Yeah.
Yes, they
Yeah,
float,
spokes.
And dimmer parts in the rings to make it look like spokes,
floating above.
but they're not in the same plane.
Oh, okay. Never heard of that. Cool.
Very interesting. Yeah.
Is Ken getting ready or?
I have an image if you like, when Ken's done.
Mhm. He's muttering.
You're on mute, Ken.
Ah,
Hmm.
You're muted.
Ken, we can't hear you.
Gonna hand move them and stuff.
You can try clicking on that.
Oh,
My mic.
something happened. We should be able to hear him now.
Yeah.
Yeah, you should be able to.
Yeah, we hear you now.
Okay. So this is about 89 5-minute subs from my Red Cat. You're seeing the Eagle Nebula and the Omega or Swan Nebula. I'm not sure what that one is. I think God's finger should be around there somewhere. David would know.
Hmm.
Yeah, it's about 5,500 light years away for the Swan and about 6,500 for the Eagle.
You did this recently, Ken?
Yeah, just last night I didn't spend any time on it because I decided I wanted to give it a good shot in SHO. This is RGB.
Were you down at Cattle Point?
Yeah, this was actually done July last year.
Hmm.
I just happened to run across the data.
But it is from Cattle Point, right?
Yeah,
Yeah.
from Cattle Point.
Looking south, I guess.
Yeah. Let's see. Sort of got everybody in the way here. Okay. But I should be able to get more detail out of it, but it just blows me away the amount of stars that are out there, right?
Mm-hmm.
It's just crazy.
They got pretty good tracking there.
Yeah, well, with that, the AM5, I was getting like about 0.2 in that, so that was pretty good, I thought.
The Red Cat's about 300 millimeters, right? Or focal length?
250.
Oh, 250. Okay.
Yeah.
So a wide field.
Yeah, definitely a wide field. There's the pillars of creation.
Mm-hmm.
And yeah, I guess we could always show you one of my starless ones. Can't seem to get away from them. But once again, you got the pillars in there and you get to see the nebulosity a bit better without all the stars there.
Yeah, it looks quite 3D. Looks like you're falling into a hole or something.
Yeah. So hopefully by next week I'll have a better one for you.
Are you gonna do a mix or?
I'm going to try it in SHO. I'd like to get some different colors. I mean, there should be blue in here and stuff like that too. So it'd be nice to see if I can get that out of it.
Nice.
And that's all I have.
That's a beautiful picture. Just beautiful. And anyone else have any, David Payne, great.
Which screen am I sharing? Am I sharing a screen?
There's a
Yes.
galaxy there.
This one? Or this one?
This one.
The second one. Okay, this is a small, really distant galaxy called Caldwell 7. It's also got an NGC number. It's 10 million light years away. and about 90,000 light years across. And it's just created it today, and it's the feature image on my latest posting on what makes spiral galaxies spiral galaxies. So I'm very interested in the talk on Wednesday because I have a theory with some strong backing that suggests that molecular hydrogen is the invisible mass that we call dark matter. So I'm curious what we'll learn during the week. Other than that, I was really interested in your Saturn description, Kirsten, because along with that, I'm posting a whole bunch of stuff about how I believe stars are created. And Saturn is, in my opinion, just a failed star. And that's how a star might nucleate. So if it was actually in a hydrogen cloud with a supply of hydrogen, additional hydrogen would get attracted to that condensed core to eventually form a star. But sitting out here around the sun, a lot of the hydrogen got blown away by the sun before it could accumulate on these planets. So really interesting night of talk for me tonight. So I finally got some more image work to start creating images. So hopefully there'll be a few more as the weeks go by.
Yay. Kirsten, I have a photo.
Fabulous, Randy.
Excuse me.
It's of you. So you see up in the up here, there's Orion and the belt, and that would be Sirius there. So this is at Cattle Point, and you were nice and still for the photo, and Margie provided the light because she had just decided to leave around that time when I took this picture. But who's this?
I think that's me, but
I think that's you.
I think a little bit of a ghost, I think. I don't look in mirrors.
A terrestrial body and an ethereal body.
That's my picture.
No, that's
But it was
great.
a very nice night. When was that? Tuesday?
I think it was we had met with it was Thursday night.
Thursday night.
Yeah, we had met with some of the Nova group, and then we went out afterwards.
That's right.
Anyway, it was a very pleasant night. Very, very good seeing. There were some wispy clouds, but the moon was like there was no waviness. It was really lovely.
That's
Yeah,
interesting.
the temperature was nice, actually. It was not chilly. It was actually like a very moderate 8, and it felt not warm, but it was really pleasant.
Yeah, it was nice and balmy. I noticed, Randy, I noticed in your photo that kind of striation because I did take a picture. I turned to the west and I actually took a picture of Boetes and Corona Borealis to see if I could get a baseline for TCRB, and I have the same kind of haze striation in it. So obviously it was there.
Oh yeah, it wasn't a perfectly clear sky, but it was not wibbly at all.
No, very nice. What did you find that evening, Kirsten? You M47 and
It was
something
actually
else.
it was M50.
Oh, okay.
It was a Messier in the Canis Major area, and then I also found actually it was wonderful. I found a double star that I'd been wanting to get for a few months, and I'm not 100% on the constellation that the double star is in, but it's in the Canis Major area, and just kind of out and to the left of Sirius. But it's a double star called Winter Alberio.
But it was
And
dim though, wasn't it? It was dim.
it was small. It was small. But it was bright in that it had like a red supergiant and like a blue companion, like with a the same as Alberio color scheme, the red and the blue, but much tinier, much less. I was for sure definitely dimmer than the normal Alberio in Cygnus, but definitively there, and with these spectacular colors, and I think it was like HR 2764, this really
Mhm.
obscure thing, but it was called Winter Alberio, and it really did live up to its name.
Well,
And
it was kind of interesting because you had to struggle a little bit to see it, but
a little bit,
it was worth the wait though,
yeah.
because it wasn't just easy like Alberio.
No, it was a bit of a tough one to get, but because of the way the atmosphere was with the haze that night, like the red star, the bigger it was like pulsing this beautiful kind of red orange glow, and no, it was actually the highlight of I was so happy I got it. Yeah, yeah.
What were you looking at it with?
I had my it's a short tube. It's a 120 millimeter. It's a 5-inch refractor. But it's got a focal ratio of about 6. And yeah, so but it's a Skywatcher short tube 120. Yeah. So it's fairly fast. But it's an achromatic one. So I use it for deep sky, kind of like it's good with doubles as well. But it's not one I actually put it on Mars, and you can see the beginnings of the false color. But as long as you don't put it on like really bright things, I love my 120.
Yeah, it's actually a really good value. I never think of it that way because I often I definitely prefer outposts, but when you look through Kirsten's scope and you look at what you can see, you kind of think that, well, the times when I see bright things, maybe I wouldn't use it, but every other time it's really good value.
I invested a lot of like I have good eyepieces, just for clarity on that. Like if I have some really nice Bader planetarium eyepieces and some Teleview eyepieces, and they make all the difference. I think with that one I put I think it was the Mark IV, Mark V zoom, the Bader zoom.
Mark 4824.
Yeah, yeah. And so I was able to kind of, go down in magnification and increase that. So yeah.
You have a long way to go for your binary certificate.
Yes. Yes, I do.
Don't want
I
us to
sure
be
do.
kidding.
Yeah, yeah. There's 110 objects in total, and yeah, I've got a long way to go.
Great.
Okay, does anybody else have any other items for this evening? Yes.
Just a couple of things. I'll have some spacey things to talk about on Wednesday. Um, one thing, if you're looking for something to do, if it's cloudy out there at 10:47 tonight, or 1:47 for Peter in the morning, there's going to be a launch from Russia to the International Space Station. and you can usually find it on live on there's this NASA Plus thing, or I actually find myself going to YouTube and just typing in NASA TV or something like that. And
What's it actually called? Is there a name to the launch,
well,
Chris?
it's a Soyuz. I would just type in Soyuz launch to ISS or something like that.
Okay.
It's Soyuz something or other, and the designations are getting more complicated. I have my YouTube trained. It just whatever is about to happen usually just comes up as soon as I go into it. So two Russians and an American are going up. We had a very unusual private space flight last week on a Dragon spacecraft. It was actually the first time humans had flown over the poles, because until last week, the highest inclination for an orbit was 65 degrees, which was a couple of was the very early Vostok flights that the Soviets did back in the 60s. But there was a private flight, and it was called Fram 2, and the original Fram was a polar exploration ship. So that was kind of neat.
Chris, I just dropped the share to the YouTube launch.
Okay, good. There you go. And the final thing I want to say is, what were we all doing and thinking about a year ago?
The eclipse.
The eclipse, that's right.
Hey,
We were spread all over the place. And some of us were here, some of us were in other places, and we're getting ready for the big eclipse. And thank God they don't have the weather that today they're having today out east that we had a year ago. I think there's it's cloudy and snowy all over the place. And
Yep, this evening I was on board the ship on my balcony looking at the best green flash I'd ever observed. So it was the precursor to the following day when we got to the thrill of the eclipse.
that's
It was
right.
great.
I don't know, Peter, what sort of weather are you getting right now?
Right here, the weather is pretty awful. It's snowing and fairly miserable, I'm afraid. So yeah, you're right. It's a good thing for folks in southwestern Ontario that we had last year's weather. It was awesome.
Yes, the morning of April 7th last year, I was in London, and it was a beautiful day there. So I had nice weather, even if all my friends in London had already left town.
Yep. We were in Texas and it was partly cloudy on the day of the eclipse.
That's right. Anyway, that's all I have to say.
Great memories.
Chris, that's a 3-year-old link. This is the one coming up here. I believe this is the one.
Okay.
It says there's 48 minutes to go. Does it sound about right?
Okay. I thought it was 10:47, but
Well, have a quick look at that link and see if you think that's the right one.
yeah.
It says Soyuz rocket MS-27 launch to ISS.
Yeah.
86 watching right now. Oh, started streaming 6 hours ago. Yeah, I think this is it.
Yeah, well, that's it. So maybe it is
Okay.
just 47 minutes. That's the right one.
Let me just flip a share over and you can see what it looks like. That's the one, right, Chris?
Yeah, that's it.
Okay.
And John Kim is the American astronaut.
Okay. Who's the other person?
There's two
Oh,
Russians.
two Russians. Okay.
Yeah. Now, actually, in one of the corners there, they're they're actually showing some footage from that SpaceX mission I was talking about last week. So,
Okay.
oh, and now
So-
they're showing some footage from Apollo 15.
Yeah, I see that. So when does the real action happen, Chris?
Okay, well, the launch. Okay, there it is.
2:45 Eastern Standard Time. So
Yeah, that may be when
one,
the coverage starts. But
two,
anyway,
three. So
in
that's
the next
11.
hour or two, the
No,
launch
that's-
is going to happen.
That said April. That said 2021.
Yeah, I think that's right.
Okay.
You have to shut down over here in the Fairfield Community Center.
Yeah, well, you
Has run out.
Oh, right. Yeah,
Okay.
you guys have got to go. Okay.
Anyway, just
All right.
just look around, you'll find it. Sorry.
Yeah.
Sorry for the confusion, but
Okay. Thanks, Kirsten, for
Yeah.
for leading us along. Lovely.
great
Okay,
job.
Thank you.
And
Okay,
we'll
good
see
night-
you all.
good
We'll
night,
see you all
everybody.
on Wednesday. Come on out
Yep.
to the
See you Wednesday.
University. Yeah.
Right
Bye.
on the taskbar. So